Before we move forward, we've got to define some terms. The first thing we need to define is what we mean by a square root being simplified. So part one is that there's no perfect square factors in the radicand. Well, what does that mean? We'll use an example to explain it. If we had the square root of 8, 8 is the radicand, and that has a perfect square factor of 4. And that's why we can simplify this further. The square root of 4 is 2, so this becomes 2 root 2. Our radicand is now positive 2, and that doesn't have a perfect square factor, so this is considered simplified. So that's the first thing. The second thing is there are no fractions in the radicand. So for example, the square root of 15/4 is not considered square root. It's not considered simplified because there's a fraction inside the radicand. The radicand is 15/4. We would need to take this further, and in this case we could probably just break it up into the square root of 15 over the square root of 4, but the square root of 4 is 2. So now all we have is the square root of 15 over 2. There's no fraction in the radicand. There's a fraction in the problem, but the radicand is just 15 now, so it's represented properly. That's the second thing. The third thing, and what we're focusing on today really, is that there are no square roots in the denominator. No square roots in the denominator. An example of that would be something like 4 over the square root of 3. And this is not considered simplified because the square root of 3 is in the denominator. So that's what we need to deal with. Now there's a name for dealing with this. The process of removing a square root from a denominator is called rationalizing the denominator. If you're not taking notes, you're really missing out, but make sure you know what that means. That rationalizing the denominator is the process of removing a square root from the denominator. So let's relook at this problem. 4 over the square root of 3. I need to mention something before I forget it. What I need to mention is this. We've talked about this, and this is the idea that if you took any square root, the square root of anything, and you multiplied that by itself, you would always get the radicand, in this case a, or represented a different way. The square root of a squared equals a. And that's the idea. That's what we're going to use, that main idea, to rationalize this denominator. Now you know that we're allowed to multiply anything by 1. That's just the identity property. Because multiplying by 1 doesn't change anything's value, right? But we're going to be tricky about it. We're going to multiply by a form of 1. Specifically, the square root of 3 over the square root of 3. Right? That's just equivalent to 1. But what we want to have happen is what's happening here in the denominator. Because when we multiply those fractions together, well, the numerator would just be 4 square root of 3. But the denominator is just 3. The square root of 3 times the square root of 3 is just 3. And this is simplified. Why? Because the square root of 3 can't be simplified. There's no fraction inside the radical, and there's no fraction in the denominator. So we rationalized it. This has been simplified. Why don't you try another one like that? Oops. Why don't you try 5 over the square root of 3? Go ahead and rationalize that, and then when you're done, try 6 over the square root of 5. Hit pause and try them both, please. Let's go through it. For this first one, we just need to multiply by the square root of 3 over the square root of 3. And that would give us 5 root 3 over 3. For the second one, since the denominator is the square root of 5, to rationalize, we'll multiply by the square root of 5 over the square root of 5. We would get 6 root 5 over 5. And it's rationalized. We'll add on to this in the next video. Hopefully this makes good sense.